Hey guys, this is Miss Michelson, and I'm walking you through the first semester final exam review for geometry, and I am going to be doing the evens today. So we've got our review out, and we are going to start with number 2. So it's multiple choice question. It's asking us for the correct name of our plane. And the thing we got to remember here is when we are writing the name of a plane, that it has to include 3 letters. So out of our answer options there's only one of them that includes 3 letters. Why don't we circle C and we can write that on the line? Lucky us, we get to do number 4, which is asking us to define collinear. When I think about collinear, I'm seeing the word line right here in the center. So collinear is going to be points located on the same line. So collinear really just means same line. We are dropping down to number 6. And we're given this diagram here and we're given 2 measurements. The thing that I want to do first is label my picture so I know what I'm looking at. This tells me IOJ, from I to O to J, is 22 degrees. And from H to O to I, HOI, is 25 degrees. So when it's asking me to find the measure of HOJ, that's going to be from this H to this O to this J. It's asking me to use the entire angle. Now, your teachers may have said part plus part equals whole. I like to say small plus a small equals big, but that's how we're going to approach this problem. And I want you all to see if you can set up this equation and find your answer for HOJ. We're going to go ahead and flip over to our next page, and we are at number 8. This is asking me to find the midpoint of a segment. So imagine we had a line with 2 endpoints. We want to find that point right in the middle. And this is actually a formula that we will be given on the exam. So we don't have to worry about memorizing it, but we just need to know how to apply this formula. So basically what we're going to do is we're going to take our x values and we're going to add them together and we're going to divide it by 2. I like to think about this as like we're finding the average of the 2x values. And then we're going to do the same thing with our y values. Add them together and divide by 2. You can see that our answer, we can write it on this line over here, is going to be an ordered pair. It's not going to be one single number. So the one thing I got to know is that the x coordinates are the first numbers in these ordered pairs. So I'm going to take -8 plus 7, divide by 2. And then I'm going to do the same thing with my y's, -8 plus 8, divided by 2. And then we just need to go ahead and simplify this. And I'm going to leave that for you all to solve. Once we set it up, can you write my final ordered pair by simplifying these fractions? Number 10 is multiple choice again, and it says if ROS is obtuse, so from R to O to S is an obtuse angle, it's got to be greater than 90 degrees, and TOR is a straight angle. That means that this is 180 degrees total. Then what is our classification? What must we see happen with angle TOS, this smaller angle over here? Well, if this one's greater than 90 and it has to add up to a total of 180 degrees, this angle right here has to be less than 90 degrees. So a less than 90 degree is going to be acute. Number 12, I like that they tell us that it's not drawn to scale. We're told that MO bisects this angle LMN. Remember that bisects means cut into 2 equal parts. This angle over here is going to be congruent to this one over here. We are told that LMO is 13x minus 31, and NMO is x plus 35. So congruent means that they are equal to each other. So I'm going to take my 2 expressions, 13x minus 31, and set it equal to x plus 53. Now, if we need help solving our equation, one thing that I like to do is draw a line through this equal sign. And I need to get all of my x's on one side, and then I need to get all of my numbers on the other side. So I'll set us up with our first step. I'm going to subtract x from both sides. So I'm going to get 12x minus 31 equals 53. And then I want you all to take it away from here. Can you tell me what my value of x is? And then remember, we got to take that value of x and we're going to plug it back in to find the measure of that angle. Moving right along to number 14. It says the measure of an angle is 98 degrees. Classify this angle as acute, right, obtuse, or straight. So our angle is greater. Our angle is greater than 90 degrees. And we talked about that in one of our other problems. I'll give you a hint. It's not a straight or a right angle. Can you tell me if it's going to be acute or obtuse? Number 16 says, name an angle that makes a linear pair with COD. So I'm going to go ahead and highlight COD on my paper. That's this angle right here. And what we want to find is an angle that makes a linear pair. A linear pair, remember, is two angles that make a straight line. So if I look at the straight line of this segment OD, that has two separate angles, one here and one here, but a linear pair is just going to be one extra one on top of that purple one. So then the other line I can look at is if I cover up the top half and I'm looking at this segment here from CO, can you name this angle right here that forms a linear pair with COD? And that's going to be your answer. Number 18 is using linear pairs to help us solve for a value of x. So the thing we know about a linear pair is that they add to equal 180 degrees. They're what we call supplementary. So we got to confirm we have a linear pair here. Well, this angle has a line here and line here. This angle has the same and this one over here. These two form together to make a straight line, so all is well in the world. This totals 180 degrees. So I'm going to take my two expressions and I'm going to add them together and I'm going to set them equal to 180 degrees. That's something that we've practiced a lot in this class. And then we're going to go ahead and solve our equation here. I'm going to draw this line like I did in my last problem, but this problem's a little bit different because if we look on one side of the line, we have some like terms that we're allowed to combine. And I'm going to highlight them different colors. So the 4x and the 2x are like terms, and they're being added together right now with this plus sign. So 4x plus 2x is 6x. And then we also have these two kind of like whole numbers, 90 and 72. We can add those together as well because they are like terms. 90 and 72 is plus 162, and that is going to equal 180. Now we've got a friendlier equation that I want you all to see if you can solve the rest. I defined supplementary right up above in number 18. Complementary is the other one when we would have two angles that add to 90 degrees. So complementary, we're thinking 90. Supplementary, we're thinking 100. And then the last even number on this page is number 22. It says write the converse of the following. So this was our if and our then statements. We have if it's raining, then I should use an umbrella. The converse is just going to switch the order here. So I'm going to say if I should use an umbrella, comma, then it is raining. Oh, that's kind of hard to see. But I just took this statement and I wrote it first. And then I took it is raining and I wrote it last, but if and then stayed in the same spot. And we can go ahead and flip over. We are moving right along. Number 24, oh, I love problems like this. It's asking us to identify what's the relationship between angle 1 and angle 6. Well, I've got a 1 here and a 6 here. I'm going to highlight them. In these problems, we labeled like exterior, interior, exterior. And then our transversal, we were labeling left and right. So is there anything in common between these? One's in the interior, one's in the exterior. One's on the left side and one's on the right side. They don't have anything in common. So our answer here is none. There's no relationship between 1 and 6. Whereas if we look at number 26, which was asking us about 2 and 6, I'm going to make my same labels. We've got the exterior, interior, exterior, and we've got the left and right of our transversal. Here, 2 and 6, one's in the exterior and one's in the interior, but they are on the same side. They're both on the right-hand side. So the way we classify these on the same side, one's in the interior, one's in the exterior, we call them corresponding angles. So we can write our letter D there. 2 and 6 are corresponding. Now if we flip over, we've kind of got a multiple choice question. Same idea going on in our picture. We've got parallel lines cut by a transversal, but now we want to select which statement is false. So we're told that these two lines kind of going vertically are congruent, or not congruent, they're parallel to each other. And the measure of ABC is 100 degrees. And we've solved problems like this in geometry before, and I like filling them in because I think it's fun. But we know if this angle is 100 degrees, then this angle is 100. And we also know that if this one's 100, this one's 100, and this one is 100. So we've got 4 angles that are 100 degrees. And then every angle next to those form a straight line. They form a linear pair. So they should equal 180 when added. So if the left side is 100, the right side is 80. This one's 80, this one's 80, this one's 80. So now that I have all my information, I'm going to go ahead and look at my answer options here. It says CBE, from C to B to E, is 80 degrees. That is true. DEF is 180 degrees. That is true. DEB, that's this angle right in here, is corresponding to CBE. That's this angle right in here. They are not corresponding because they are both in the interior. These two angles are same side interior. So C must be false. Number 30, kind of similar to the last question that we just did, but we're using the figure and this value here to help us find the measure of angle 4. So kind of like I did before, if we know that this angle is 42, we know that its vertical angle over here, 5, is 42. We know that the same side, not same side, alternate interior angles are congruent to each other. So these two are 42, and then we've got another linear pair. So by knowing this is 42, I know all 4 of these angles, which must make angle 4 42 degrees. And then number 32, we're going to our slopes of our lines. Instead of just looking at our diagram, we've got some algebra mixed in here. When we're saying the slope of a line that is parallel, remember that means that they're going to be the same. So the one thing we have to know is where to look in this equation. Can you tell me what the slope of this line is? I will give you a little hint. Remember the formula y equals mx plus b. M represents the slope. And we can flip our page over. We are moving on to topic 3, which was our transformations. This was like our whale project unit. So we've just got to know how to apply these transformations. Again, these are going to be given to you, these rules on our formula sheet. So we don't have to remember anything. We just have to know how to apply them. But the first one's multiple choice and it's graph matching. I love that. You want to figure out which one is a transformation or reflection across the x-axis. Well, that means that the x-axis here should be like my line of symmetry. And for the first one, this is symmetric about the y-axis. It can't be that one. B looks pretty promising. This kind of like this mirror line. We flipped right over top of it. C is not correct and D is not correct. So our answer here is B. Number 36, we're given 3 coordinates of like a triangle, and we want to write the new coordinates after we have a rotation here about the origin, 90 degrees. Remember that if they don't tell us anything, we got to assume that it's counterclockwise. And the way that we follow this rule, or the way we apply this, is it becomes negative y comma x. So the x and y are going to switch spots. The y coordinate's going to become negative. So for A, the 7 is going to go first, and the negative 2 is going to go second, and the 7 is going to become negative. I will do B as well. The 1 is going to go first, the 0 is going to go second, and the 1 is going to become negative. I want you all to try this last one for me. Number 38, transformation described over here, is a translation. Remember, that's like a slide up, down, left, and right. This 2 tells us that we take our x value and we add 2 to it. And that negative 6 tells me that I take my y value and I subtract 6. So I kind of like to line these up here. Negative 2 plus 2, my x values is 0. 7 minus 6 is 1. And I'm going to do the same thing for B. I'm going to add 2 to my x's. 0 plus 2 is 2. And I'm going to subtract 6. 1 minus 6 is negative 5. I want you all to solve problem C for me. And then our last transformation problem on this page, number 40, is describing a composition of transformations. So if we look here in our notation, we have 2 transformations written out for me. I've got a rotation, lowercase r, and then I've got a translation, capital T. The one thing that we got to remember is that the transformation closest to our shape is the one that goes first, and this one goes second. So I'm looking at my answer options. The only one that has a translation first is either A or C. So I know B can't be the answer, and I know D can't be the answer. So now I want you to take a look at the difference between the two. The translations have the same values, left 4, up 2, and the only word that's different here is clockwise versus counterclockwise. So remember what I set up above for number 36. Use that to help you figure out, is the answer A or C? And now we're moving on to triangles. I think if I had to pick a favorite, I love these triangles. We're solving them. So one thing we know about triangles is if we take all 3 angles inside of our triangles, we should add up to 180 degrees. And we'll see that play out in a couple different ways on this paper here. But this one, I'm told at least a little bit of information about all 3 of the corners. So my first angle here, I'm just going to say is 2x. My second angle here is going to be x minus 10. I'm going to take that whole thing. And the angle number 3 is 55. And I know when I add them up, it should equal 180 degrees. And we had an equation like this kind of a while back now. If we take a look at this left-hand side of our equation, there's some things that we can simplify first. So let's see if we can identify our like terms. The 2x and the x we can add together. And then the negative 10 and the 55 we can add together as well. 2x plus x is going to give me 3x. Negative 10 plus 55 is going to give me 45. and this equals 180. And I want you all to see if you can solve the rest. Number 44, there's a couple different ways that we can solve this problem, but I'm just going to use kind of our formula that we talked about in class. When we have an exterior angle out here on the outside of our triangle, this is equal to the sum of the two opposite interior angles, interior meaning inside the triangle. So 117 is going to equal to the sum of these two. X plus 66. Now we're trying to solve for x in this equation, which means we want to get x by itself. So we got to move this 66 over to the other side of that line. And I want you all to finish up the rest of that question for me. Number 45 does that problem, but it works it out backwards. So think about the relationship between these three values. And we flip over to number 46. This is our congruent statements. Remember, we were color coding these in class. We're talking about how order matters when we're solving these problems. The M goes with the V, the N goes with the W, and the O goes with the X. So it says pick the statement which is not true. So let's take a look. NO is purple blue. VW is green purple. Right off the bat, that is not the same order, not the same colors. So I'm thinking that one might be wrong, but we got to check these other ones too. O and X are both blue. N and W are both purple. And then MOVX, those ones check out. A is the incorrect answer there. And then we're moving on to 48. Identify the congruence or postulate / theorem that proves the triangle's congruent. So there's one thing that jumps out to me about this triangle, and it's that they are overlapping. The triangles share a side. They're kind of like touching. So this side here from H to Z is in both this top triangle and in the bottom triangle. So what we know is whatever this length is, it's going to be congruent to itself. I'm going to add those congruent bars. And now let's interpret what else we've got going on. We've got another side here that matches up with this side here. They have one marking. And then we have this one that has two and this one that has two. So if all three sides are marked on both of my triangles, this is my congruent statement, side, side, side. That marker is having some trouble. Side, side, side. And what we want to do is finish the congruent statement here, which again is just following this order. JHZ is the same thing as VHZ in my second triangle. And then we've got a similar question in number 50. It says, which of the following statements is true? And we can take a look. We've got a couple different congruence theorems and then a couple different, what is this called? A congruent statement. That's what it is. So my guess would be to ignore this at first and then see if you can solve the question on our own and then see if our answer is over here. So if I take a look at my picture, I've got a marking here which matches up with here. We know that that is a side length. We've got another side length here and here, but just like in our last picture, our triangles are overlapping. They share this angle over here, and we've got a special set of angles that is formed. These are called vertical angles, and vertical angles are congruent. So in my picture over here, I have a side, an angle, and a side. And in this triangle over here, I have a side, an angle, and a side. So my congruence theorem should be SAS. This is not true. This is not true. I want you all to decide whether this is going to be B or C. And we've got one last congruence theorem. This one is a little tricky if I do say so myself. I see right away that I've got a right angle in my picture. And I know when I'm thinking right angle, I'm thinking hypotenuse leg, but we have to make sure that we have the hypotenuse and the leg in our picture marked. The hypotenuse is always the slanted side, so CD is the hypotenuse and AD is the hypotenuse, and neither of those are marked, so it actually can't be hypotenuse-like. So what that means is that this right angle and this right angle just go back to being regular angles. We know that this angle is congruent to this angle. And then just like we did in the very first congruence triangle congruence problem, we have this overlapping or this shared side. So BD is congruent to itself. So in both of my pictures, I have two angles and a side. Two angles and a side means AAS. And then the last one on this page that we get to do is number 54. Got lots of parts to it, but I like this question. So it says in the diagram below, AC is the perpendicular bisector of BD. So that means where they intersect creates a 90-degree angle that's perpendicular. Bisector means that it's going to cut this into two congruent parts. This is congruent to this. So if BD, this entire length, is 36, we want to find the value of x, and then we got some other segments in there that we need to find. So if I know that this part over here is 3x, then I must know that this side over here is 3x as well, because they're congruent to each other. And again, we've got small plus small equals big. 3x plus 3x equals 36. We've got some like terms that we can add together. 6x equals 36. And then can you solve the rest of this one out? Once you find x, you should be able to find the length of ED. So you're going to plug that in to find this one. And then AD and DC are just sides or like outsides of this figure here. Ask yourself which segment that I'm given matches up with AD. And then you got to ask yourself which segment that I'm given matches up with DC to find the rest. But I believe that you all can finish that one on your own. And we just got a few more problems left, believe it or not. Number 56 is an isosceles triangle. And what we know about isosceles triangles is that they have two congruent sides. So they tell me that, and they also give me the markings, which is nice. And in an isosceles triangle, the angles below those congruent sides are called our base angles, and they are congruent to each other. So if I know that this angle over here is 30 degrees, then I know that this angle over here is 30 degrees. And then this just becomes one of our triangle problems. How do I solve for one missing angle in a triangle? Well, I take the two that I know, and I add them together. 30 plus 30 equals 60. And what do I do with that 60? I'm going to leave that up to you. And then number 58 is asking me to identify the largest angle of triangle ABC. I'm given a lot of information over here, but I think I'm going to best be able to answer this question if I see this as like a picture, if I draw the triangle out. So that's exactly what I'm going to do. This is one of our strategies that we might want to use on our final. If we draw our picture A, B, C, then we should be able to label the sides. From A to C is 9, from C to B is 10, and from A to B is 11. And we know that there's these relationships in our triangles that the largest angle is going to be across from the largest side. So my largest side is this right here, 11. The angle directly across from it, that letter that's not included here, is angle C. So our largest angle is going to be angle C. And we're flipping over. Number 60, name the figure below. You name a figure by the number of sides that it has. So all we have to do is count the sides. 1, 2, 3, 4, 5. I would say n equals 5. Do you know what we call a 5-sided figure? You should have this table over in your notes, and you can figure out what we call it if you don't know already. Number 62 is similar to 61 and 63. We've got two missing values that we want to find. And this is using a little bit of our geometry that we've already talked about in this video. When we have two angles next to each other and they form a straight line, remember that their total is 180 degrees. So without even using that quadrilateral at all, to find my missing value of x, I'm just going to take 180 and I'm going to subtract 114. And that's going to give me 66. I hope I did that right. So I know x is going to be 66. Now, I really don't care about that exterior angle anymore. Now I'm just looking at my quadrilateral. And my quadrilateral problem, I'm going to solve very similar to how I solve my triangles. Remember, when you take all four angles and you add them up in a quadrilateral, it should equal 360. So to find one of the missing values, all you have to do is add your three numbers up and subtract it from 360. And I'm going to let you all do that one on your own. Number 64. This is another one where they tell me that I'm dealing with a parallelogram, but they don't give me a picture. So I would like to look at a picture here to help me solve this problem. LMNO just means I'm going to go in a circle and label this. I'm told that ON, from O to N, is 7x minus 5. From L to M is 6x plus 3. From M to N is x minus 4. And OL is 2y plus 5. So the thing we want to know here in our parallelograms is, how are the side lengths related to each other? Well, kind of like our rectangle, something that we're more familiar with, the opposite sides are congruent. This is the same as this. This is the same as this. So that's going to help us set up some equations. If I want to solve for the value of x, I'm going to take these two equations right here. Congruent, remember, means equal. 6x plus 3 equals 7x minus 5. I'm going to go ahead and solve my equation by subtracting 6x from both sides. I'm going to be left with 3 equals x minus 5. And then I'm going to move this 5 over by adding 5. X equals 8. So that helps us find our value of x, but now we want to find the value of y. And y is attached to this segment here, LO, which we know is the same thing as x minus 4. So congruent means we put an equal sign in the middle, and then we solve this equation. But our problem is that we have two variables. We can't solve it if we have two variables. But we know our x value now. We just found it right over here. So I want you to plug in x, and then I want you to solve the rest of your equation for me. And we never thought we would get here, but we are at the back side of our paper. We've got another parallelogram, but now we're dealing with the angles. So we got to remember, how are the angles in a parallelogram related to each other? We say the opposite angles are congruent. So along these diagonals, those two are the same, and these two are the same. But what is the relationship between the angles that are side by side? They are supplementary, or they add to 180 degrees. So if I have one of each color, I've got to add them together. 97 plus x minus 5 equals 180 degrees. If I look at the left side of my equation, there's some things that I can clean up over here, some like terms. I have a 97 and a negative 5. 97 minus 5 is 92. And now I've got a two-step equation that I want you all to figure out for me. Number 68, find the value of x in the kite below. So for my kite, and if I'm trying to find x, I know that I'm going to have to deal with this 2x minus 14. So my question is, which one of these numbers do I use? Do I use both of them? Do I use only one of them? Is there something they're not telling me in my picture? And the thing we got to know about our kites is we've got two congruent sides. I like to say that this small one matches up with the small one. And then this big one matches up with this big one here. So if this side right here is 32, then this one must be 32. And if this side right here is 20, then this one must equal 20 as well. So we're really just solving the equation 2x minus 14 equals 20. And then truly this 32 was extra information. We didn't need that. And last but not least, number 70, in the rectangle below, OAD, that's the length of this diagonal, is 39. And OL, the length of this diagonal, is 3x plus 12. The one thing we know about our rectangles is that our diagonals are congruent to each other. AD is going to be congruent to OL, which means this value here, 39, should be equal to 3x plus 12. And let's go ahead and solve that out. I'm going to subtract 12 from both sides. 39 minus 12 is 27 equals 3x. And I'm going to divide both sides by 3. X equals 9. And now what we want to do is we got to find the value of y. And y is this tall side. Not tall, I guess it's like my height of my rectangle right over here. And remember, one of our strategies is to set up our triangles in our problem. We don't know what this side is. We know this length here is 36, and we know it's a right triangle. And we just figured out what AD was. Or actually, they tell us AD is 39. So how do we find the missing side of a right triangle? We have our lovely Pythagorean theorem. A squared plus b squared equals c squared. Remember that c is direct across from our right angle. It's always that slanted side. It's our hypotenuse. So I'm going to put in a 39 here. A and B, doesn't matter which one it is. I always like to take my number and plug it in for A first. I don't know. I leave B in my equation a lot. B is going to be my question mark. And then I want you all to solve this for me to get your final answer. And that, my friends, is the semester 1 final exam review for geometry. If you have any questions, let me or your teacher know, and I will see you all in the next one.